This is Algebra 1, Lesson 6.2. We are solving multi-step inequalities, just like multi-step equations, with one specific difference. You reverse the symbol when you are multiplying or dividing both sides by a negative number, beginning on page 340. Example number 1 is using more than one step. 5 over 6 times x, or 5 over 6x, minus 2 is less than or equal to 18. Remember, you work your order of operations. Please excuse my dear Aunt Sally. You work it like that when you simplify in one side, but if you start undoing, you go backwards. You do Aunt Sally first, then my dear, then excuse, then please. So for this first one, we want to undo any addition and subtraction first. We see that it says minus 2, so we add 2. If you add it to the left side, you add it to the right side. Remember, you do it to both sides. That leaves you with 5 over x. 5 over 6x, excuse me, is less than or equal to 20. Now you want to undo the fact that it says that was addition and subtraction first. That's gone. You want to undo any multiplication and division. We have 5 over 6 times x. Remember, you undo multiplication by dividing. But since we're dividing by a fraction, remember, we can undo dividing by a fraction by multiplying by its reciprocal. 5 over 6 multiplies by 6 over 5. It's reciprocal. It's the same thing on both sides. So you multiply each side by 6 over 5. What you have now is 20 times 6 over 5. Remember, 20 is over 1 when you go straight across. Or you could cross cancel if you notice that both 5 and 20 have a common factor. 5, it goes into itself once, and into 20 4 times. So you're dealing with smaller numbers if you do it that way. 4 times 6 gives you 24. Notice the symbol stays just like it is. It doesn't reverse. Less than remains, or equal to remains less than or equal to, because we divided by 5 over 6, or we multiplied by 6 over 5, not by a negative number. On the back, everybody, let's try this one. 5x minus 3 is greater than 12. Get x by itself. Undo your order of operations backwards. Take 30 seconds. Okay, again, just like as if it were an equation. If you need to draw the line, draw the line. There's nothing wrong with that. X is at the bottom, except now we're not trying to make equal to. We're going to either make greater than or possibly less than if we have to. You undo addition and subtraction first. It says minus 3. You add 3. If you add it to the left, you know you have to add it to the right. It leaves you with 5x over here. 12 plus 3 is 15. We do not have to reverse the symbol in this case because we did not multiply or divide by a negative number. So it stays just like this. Now it says 5 times x. We're finished with addition and subtraction. Undo multiplication of 5 by dividing by 5. When you do it to one side, you do it to the other side. 15 divided by 5 is 3. Again, one last thing you got to check, and the only thing that's different with inequalities versus equations, do you need to reverse the symbol or not? Had we divided by a negative number on both sides right here, 5, we would reverse the symbol, but since we didn't, we'll leave it just like it is. X is greater than 3. Also remember this, if it asks you to graph something like this, remember we did this a long time ago. If you had to graph this, if 3 was right here, remember it's an open bubble since you're not counting 3, and it's everything greater than, everything larger than 3. You have to remember to be able to do that as well. Example number 2 is multiplying or dividing by a negative number. So this is when you have to multiply or divide both sides by a negative value, reversing a symbol. 9 minus 3t is less than 7 plus 2t. Not only is it multiplying and dividing by a negative value, we have variables on both sides. We know how to solve equations with variables on both sides, no problem. Normally we would bring the smaller variable term over first and then bring the other term over. But since it wants to show you by a negative number, it brings the 9 over first. Doesn't matter what order you do it in. It's positive 9, so you subtract 9. When you do it there, you got to do it here as well. 7 minus 9 is negative 2. with inequalities. This is the reason they didn't bring the smaller negative 3t over. With inequalities, it helps tremendously to have your variable on the left side. It makes graphing the problem so much easier. So since that goes to the right side, you want to bring the 2t or the positive 2t over to the left side. It says plus 2t. You subtract 2t there. And when you do it there, you have to do it here. So negative 3t minus 2t is negative 5t. Negative 5t is less than negative 2. Undo negative 5 times t by dividing each side by negative 5. So what you have is negative 5t is less than negative 2. Divide this by negative 5 and divide this by negative 5. A negative divided by negative is going to be a positive 2 over 5. T is going to be left alone. But in this case, notice we divide by a negative number. When you divide by a negative number on both sides, you reverse the symbol and less than becomes greater than. So t is greater than 2/5. So the solution is all real numbers greater than 2/5. And again, if you were to graph that, you would go to 2/5, which is 40%, 4 out of 10, a little bit less than half. And you would say everything greater than that, an open bubble, everything going to the right side of it. Again, on the back, everybody, let's do this one. Or let's do the first one. I'll uncover B after that. Solve the inequality. Negative 3x plus 1 is less than or equal to 22. Take 30 seconds. Again, order of operations backwards. If you need this, put this. Nothing wrong with doing that. X is going to stay right where it is on this side. Undo plus 1 by subtracting 1 on both sides. Negative 3x is left. 22 minus 1 is 21. Ask yourself, do I reverse the symbol or not? All we did was subtract it. We did not multiply or divide by a negative number, so the symbol stays just like that. Undo negative 3 times x by dividing by negative 3. Do the same to the other side. A positive divided by negative is a negative 7. Since we divided both sides by a negative value, we're going to reverse less than or equal and make it say greater than or equal. That is the only difference between inequalities and equations. Again, let's try this one right beside it. Take 30 seconds on this one. Negative x plus 1 is less than or equal to 3x plus 21. Again, just like on the example, we have variables on both sides. Instead of bringing our smaller negative x over to our larger x side, there's nothing wrong with doing that. We want to leave our variables on the left side. It makes graphing it tremendously easier. That being said, let's bring plus 1 over by subtracting it. If you subtract 1 on the left, you have to do the same to the right. 21 minus 1 is positive 20. So you still have 3x there. You still have negative x on the other side. And all we did was subtract 1 on both sides. So less than or equal to is going to stay just like that. Undo the fact that it says positive 3x by moving that over to that side. It's positive, so undo it by subtracting 3x. You do it there, do it here. Negative 1 minus 3x is negative 4x. That canceled out and leaves us with positive 20. Again, We did not multiply or divide by a negative number. Only when you multiply or divide by a negative number do you reverse the symbol. So the symbol stays just like this, doesn't change. Now we want to get x by itself. It says negative 4 times x. We divide by negative 4. When you do it to the left, you have to do to the right. Positive 20 divided by negative 4 is negative 5. In this instance, we did divide both sides by a negative number. So the symbol has to reverse from less than or equal to greater than or equal. X is greater than or equal to negative 5. Example number 3 says writing and using a linear model. Long distance calls, you pay 45. It says not 45 cents per minute, 0.045 per minute for long distance. So that's like 4.5 cents for long distance. And a monthly fee of $5. How many minutes of long distance can you use to keep within your monthly long distance budget of $20? So your budget is $20. So this is the biggest problem that students have with inequalities. Most people can write an equation. If I said make it equal to 20, most people can come up with, okay, well, 0.045x plus $5 is equal to $20. Most people can come up with that without a whole lot of problems. 4.5 cents times the amount of minutes plus the fee is $5 has to be equal to 20. The hang up that some students have is if I want to change this symbol here, if I want to change it to where you could stay within your budget, you have to think, what does that mean? Are you capable, based on what it says up here, of spending $20.01? That's what you have to think. Can you go over $20? No. This says you have to stay below $20. So what it's saying is everything on this side, all of this put together, has to be below $20, which means 20 has to be greater than what's on the left side. Greater than, in this case, or equal to. So this says right here, the amount spent on calls plus the monthly fee must be less than or equal to. And that's the symbol I have replaced. You have to do some thinking on that, not just plugging values in. So we got a verbal model here. Cost per minute times number of minutes plus the monthly fee has to be less than or equal to the monthly budget. And that's what we just made algebraically. So algebraically, these are all of the labels. Cost per minute is 0.045. The number of minutes is M. I used M instead of X. M, variable. Monthly fee is 5. Monthly budget is 20. So algebraically, 0.045M, all I did was put X, again, variable, plus 5 has to be less than or equal to 20. When you simplify that, you subtract 5 on both sides. So that's what we have. 0.045 M plus 5 is less than or equal to 20. You subtract 5 on both sides. So 0.045 M, 045 M has to be less than or equal to 15. And then divide by 5 on both sides. To get M's value, there's no reason to reverse the symbol because you're dividing by positive 0.045. 15 divided by that is 333.3. So what this is saying, just to go on to the next slide, what this is saying is dividing that, M has to be less than or equal to 333.3 minutes. So what this is saying, if you spend 334 minutes, let's just go to the next minute, talking online or talking long distance, you won't have enough money to pay your bill. So you can do 333 minutes or less. This is what the graph looks like. Your graph begins at $5 and it goes up. Its slope will look like that. At 333 minutes, you're going to hit $20. If you go past that, you're going to go above $20, which will not allow you to pay your bill for the week or for that month. So right here, checkpoint says 17 minus x is greater than or equal to 12. We want x by itself. Subtract 17 on both sides. Negative x is greater than or equal to 12 minus 17, negative 5. Divide by negative 1. When you do it there, do it here. Negative divided by negative is a positive. When you divide both sides by a negative, you have to reverse the symbol. Less than or equal to 5. Variables are on both sides. Bring your smaller x or bring it over to where your variables are on the left to make it easier. Subtract positive x. Do it here. 3x minus x is 2x plus 2 is negative 8. Remember, all we did was subtracted. No reason to reverse the symbol. Subtract 2 there and here. Negative 8 minus 2 is negative 10. 2x is still on that side. All we did was subtract 2. No reason to reverse the symbol. 2 times x, divide by 2 on both sides. Negative divided by a positive is a negative 5. Now, here's a hang up for some students. It's a negative 5. Do you reverse the symbol or not? No. We're dividing by a positive 2. See how it's positive on both sides? You do not reverse the symbol unless you're dividing both sides by a negative number. And the last checkpoint problem says your school carnival charges $2 for admission and 50 cents for each game. You go to the carnival with $5.50, write and solve an inequality. What is the maximum number of games you can play? So just like the equation we did for the example, 50 cents times x plus $2 has to be less than or equal to 550. Subtract 2 on both sides. 50 cents times x is less than or equal to 350. Divide by 50 cents on each side. 5 goes into 35, 7 times. And there's 3 decimals we have to move. So it's going to be x has to be less than or equal to 7 times. X is less than or equal to 7 times.